So the next video is on Coulomb's law, and this covers chapter 23.5 in the textbook. Okay, so in the previous video we talked about forces. So we have two kinds of forces, positive and negative. And so again, the direction of the force is determined by the relative sign of the forces. So to first order, neutral objects don't attract or repel, although we'll see some interesting exceptions, I guess you could think of it, in class. So opposite charges attract, like charges repel. And so now we're actually to the point where we can talk about exactly what the magnitude of this force is. And there's a relationship called Coulomb's law that'll tell us exactly what the magnitude of this force is. So the electrostatic force, we're going to call it F sub E. Well, it's directly proportional to the magnitude of the charges, right? So you've got two charged objects. One of them has charge Q1, the other has charge Q2. So the bigger the charge, the bigger the force. So Q1 times Q2 on the top. It's indirectly proportional to how far apart they are. So that's this R. So R is the distance between object 1 and object 2. And we divide by R squared. So the further apart they are, the weaker the force gets. And we also need this constant of proportionality, which we're going to call K, which is sometimes called Coulomb's constant or the Coulomb law constant. So there's two different ways we can write this equation. So on the left-hand side here, so this is just telling us the magnitude of that force, not the direction. So that's why there's little absolute value bars around the Q's here. Because this says, okay, I'm just going to forget about the positives and negatives. I'm going to figure out the magnitude, how big the force is. Then to figure out the direction, well, I just look to see whether they're positive or negative and figure out whether it's going to be attractive or repulsive. And that's how I'll figure out the direction. Now in practice, you can also actually write this in a vector form. So this is now the force on object 2 due to object 1. And here you actually would include the sign of the Q, so whether the charge is positive or negative, and you have this R hat unit vector which points from 2 to 1. And you need a negative sign to make the directions work out. Personally, the way I usually do it is with the one on the left, I just figure out the magnitude of the force, and then I just look to see if they're positive or negative, to see attractive or repulsive, and figure out the direction that way. To be honest, I think that's easier than trying to figure out what direction all these R hats and things are supposed to be. So, as I mentioned, so R is the center to center distance. So the center of object 1 to the center of object 2. And Coulomb's constant K, so this is something you actually have to measure experimentally, it's 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. Okay, so just some comments on Coulomb's law. So Coulomb's law is what's called an inverse square law. So remember, it depended on 1 over r squared. So this says that the magnitude of this electrostatic force is inversely proportional to the square of the distance. So if you have two objects and there's some force electrostatic force between them, if you move them twice as far apart, well, the inverse square says, well, twice as far, so 1 over 2 squared, I get 1/4 of the force. Or if you want to go the other way, imagine you've got your two objects some distance apart. If you move them so they're half the distance, so that now they're closer, so then the inverse square says, well, it's going to be 1 over 1/2 squared, so you get 4 times the force. And we'll do an example in class, but let's say you have several charged objects, and let's say you want to find the force on one particular object to a bunch of other charged objects. Well, to do that, the way to do it is you find the force from each charge individually, then, right, so you've got a bunch of forces acting on the one you're interested in, then you find the vector sum of all those forces.